we have with us Mr. Abhimanyu Singh. He is the technical lead to ANSYS India academic program, serving customers across India, ASEAN, and SAARC region. He has been with ANSYS for 3 years now and has over 13 years of rich experience in CFD and FEA-based modeling and simulation expertise for industrial applications. Before joining ANSYS, he was working with L&D as design manager in Technology Upgradation Group. He has published 12 papers in national and international conferences and journals. His area of interest lie in fluid flow, heat transfer, user-defined functions, linear and non-linear static and dynamic simulations, electrification, and digital twin. Mr. Abhimanyu holds a master's degree in thermal and fluid engineering from IIT Bombay. In his current role at ANSYS, he is working closely with educators, research scholars, academic institutes, curriculum, and skill development partners for efficient adoption of ANSYS tools and technology. So we welcome you, Mr. Abhimanyu, and you have the floor.
Thank you for this opportunity, and thank you for this generous introduction. And I was listening to Dr. Sarkar and Mr. Ghoshal. It was really inspiring and a lot of learning for me as well. And many questions came on the employability part. So I have put together some element of that I'll be touching base on, and how we are at ANSYS are also trying to contribute to this industry academia ecosystem. Is it okay if I switch off the video, because during Google Meet it sometimes crashes when I present my screen. So during
Yes,
Q&A I'll
you
take
may
a
do that. Yeah.
Let me start sharing my screen, because we don't use Google Suite, so sometimes that creates an issue. I'm not getting an option of sharing my screen. Can you please confirm if I'm a presenter?
A second, I'm just checking.
In the taskbar, there's an
it's grayed out, sir. It's grayed out for me. So probably
upward arrow. Is it grayed out?
Yeah, let me try again. Now it's enabled. It says you're not allowed to share your screen.
The access has been given to everybody.
Let me try. Okay, should I rejoin? Will that help?
You could try that.
Yes. It worked for me.
Okay, so I'll try that.
Let me make a quick comment in between as it jumps in. I really get incensed when I hear this word from many people, many students in particular. Apparently, they are told they are not employable. It really incensed me. Basically, they are losers. They are misfit. Probably you are wrong, barking at the wrong tree. You should not even go there. If somebody says you are not employable, you have spent 16 years of your life on a premium institute with luminary alumni. So yeah, you are no doubt. Just don't accept it.
We hear you, Dr. Sarkar, and I hope all the students here are also hearing it, and they get they have got better insights from the sessions today, and they feel more encouraged.
Absolutely.
Probably Google Chrome was not working. So are you able to see my screen in PPT?
Yes, so we are able to see it.
So is it in full screen now?
Yes, it is in full screen.
Okay. Okay. So good evening and thank you. Sorry for the delay because of the technical glitch that happens with Google Meet for me. I don't know why. So I basically lead that ANSYS India academic program, and I have been associated with ANSYS for 3 years. So I feel privileged working directly with academic customers as well as users, students, professors, and educators for various initiatives. And in the next 20-25 minutes, I'll talk about ANSYS and how simulation is the key enabler for student career. Many of the questions came on the employability index. So I'll be touching base on that and also some aspect on the future skills. So this will be the agenda of my talk. First, I'll start with a very brief introduction to ANSYS. Then we'll look into the challenges and drivers from the industry perspective and also from higher education market. We'll talk about future skills from one industry perspective, but you can extrapolate to other industry segment as well. Then I'll talk about ANSYS academic program, how we are engaged on the field and how we are working closely with various educators and institute. And last but not the least, given that audience has many students, I'll talk about the various learning enablement tool in the learning resources part, which will be particularly helpful for your teaching and research. So let me introduce ANSYS briefly, who we are and what we do. So founded in 1970, we have been in simulation industry for over 50 years now, with office spread across 85 locations, 4,800 plus employees, and 150 plus channel partners globally. We are into engineering simulation and focused at what we do, with a market cap of $32 billion and a proven track record. ANSYS is also a member of prestigious S&P and NASDAQ 100 index. Our overall customer satisfaction stands at 89% as per 2020 data, and we continue to scale that further. Now, if we look at where we are and how we started, so you probably would be familiar with ANSYS a ANSYS as having solutions for mechanical where we have structural and CFD. So we started as 50 years ago with core mechanical and structural analysis solver, where you are solving, say, second order partial differential equation using Euler's equation. Then we acquired the ability to solve fluid dynamics problem, where you are solving Navier-Stokes equation. Then we acquired the ability to solve electromagnetics problem, where you solve Maxwell's equations. So over the years, if you see, we have acquired the ability to provide you the best of breed individual physics solvers. And while we continue to innovate in each of these solvers, what we realize is that customers wants to do multi-physics simulation because products are growing in complexity. So the interaction between various physics are something you have to take care of, and that is where our USP lies. So over the last couple of decades, we have invested close to $4 billion in technology adoption over 26 plus different acquisitions. And significant part of this investment, if you see, is about around new technology areas, latest being ZMAX, which we acquired, the announcement was made in the late 2021. Now, apart from acquisitions, we have also been partnering with various technology enablers to develop and implement the virtualization that industry needs to build a new generation of products and components. So as a company, we have focused on empowering our customers to say design and developing transformational products in advanced areas such as electrification, autonomy, ADAS, 5G, additive and digital twin. So as the digital and physical world becomes one, our products are also growing in complexity, and companies are facing unrelenting pressure to innovate, lower cycle times and reduce cost, while also increasing quality and eliminating risk. So simulation is becoming very pervasive within the entire engineering expertise, from say digital exploration to digital prototyping to digital twin. So ANSYS gives you the tool to tackle the complexity of say designing, manufacturing and maintaining your product and processes. So you can also expand your simulation activities throughout your entire product development lifecycle. Say design validations to exploring various what if scenarios, facilitating innovations, then lowering development and operational costs, and also improving the time to market. Now, ANSYS enables you to predict with confidence that your product will thrive in the real world, and industry leaders use ANSYS to create complete virtual prototype today of a complex product and systems. Some of the areas you heard from Mr. Ghosal talking about having a knowledge of say, mechanical, electronics, or embedded software components. These all goes into designing the transformational product and technology that we see today, and which also incorporates all the physical phenomena that exist in the real world. So these are some of the world-class companies leveraging our platform. Now, what are the challenges and drivers in reshaping the higher education market? But before we go there, let's understand what are the key disruptions which are happening in the industry space, which directly impacts jobs which are available today and also helps us understand the future skills needed for the jobs in future. So if you talk about the key disruption, automotive is definitely going through some major disruptions, but technology advancements in these areas are going to be crucial element in various other industry segments as well. Now, electrification continues to be number one spot because a lot of supports are also coming from the government. We are seeing an increased traction in the research and development, seeing design and development associated with various electrified fuel cells or like hybrid vehicle systems. Then in autonomous system, if you talk about ADAS system finds more relevance from the safety point of view. You see a lot of autonomy and features being bundled in the modern car today, such as you have lane assist control, you have adaptive cruise control, you have automated emergency braking, and so on. And simulation is most critical element in realizing the dream of full autonomous vehicle, where we are talking about level 4 and 5. From the serviceability point of view, there is a growing interest in collecting data from operating vehicles for predictive maintenance. And this will gain even more importance for commercial vehicles where downtime can have a bigger impact on fleet performance. And this is powered by advancements in next generation communication systems such as 5G and 6G. Last but not the least, advanced materials and new manufacturing process. So if you look at the product innovations, nearly 70% are related to the development of new materials or the combination of the existing materials in the development in the different manner. There is a growing interest in the age of electrified, connected, and autonomous system for developing new materials and manufacturing processes for weight reduction, cost reduction, and part elimination. So what are the three demands which are reshaping the higher education market? If you talk about industry, they want good talent of engineers to lead innovations that is needed to thrive today. Student wants better employment opportunities, and if you talk of government perspective, we want more competent workforce with skills needed by future engineers. And these are some of the aspects which were touched by our previous speakers. So these are helping propel a way of students seeking additional qualifications beyond the first degree. Now, if you look at this is one of the survey done by Gallup Strata to understand what students are requiring and what employer requires. So this was a global survey, and basically student wants to be successful in the job market. They want to be able to get a job. They want to be successful in the workplace, and employer wants the student coming out of college to be really proficient that is needed for the job. And we know there is a skill gap. Essentially, your inability to apply the theory and concept you learn in the curriculum directly in the industry. And if you see the survey result, it tells you approximately 2/3 of the students coming out of college do not feel confident of being successful in the job market. Probably a couple of questions stemmed out from that feeling itself. And only 35% students feel confident to be successful in the workplace. So that is where we understand there is a gap in what we are reading the curriculum today and what industry today demands. And if you also look at employed survey result, they feel only 42% are employable or workforce ready. And that is where you see majority of the industry today, they give an onboarding on-ramp kind of a training. So when I started, say, my journey in L&T, I went through a rigorous training of 6 to 8 months to actually, when they would put me on the live project and they could call me billable. So this also necessitates the need to impart skill-based knowledge, focused training, and also devise a scalable solution that can be open for everyone. This is also a mega trend being observed in the future of engineering education today. So I'll take one of the example. So I'm going to take an example of automotive engineering, which is seeing some major disruptions, and the observations are going to be valid for every discipline. So I'm going to extensively quote excerpts from a white paper, which is Mobility Engineer 2030. This is a collaborative initiative led by FISITA, with contributions from FISITA corporate members, FISITA Technical and Education Committee, and also Academic Advisory Board. This essentially talks about the necessary skills needed for future mobility engineers and the skills needed to make students more employable and workforce ready. So if you look at how automotive industry is changing, there are three major revolutions which are reshaping the automotive industry. This is represented by the corners of the triangle here. Let me check if I'm able to take pointer. Okay. So first is the energy revolution. Second is the intelligence revolution, and third is the connectivity revolution. So we are all aware of the connectivity revolutions, which basically talks about smartphone, smart devices, and the range and power the connectivity brings in with the ecosystem of, say, telco technologies. When we talk about intelligence revolution, we are talking about use of data analytics, artificial intelligence, and machine learning for saying decision-making process, and to make the system more efficient. Finally, energy revolution is about tapping in renewable sources such as solar, wind, tidal, and so on, and the impact it can create in the automotive technology. So in the next phase, we are seeing these three revolutions are coming in together to reshape the automotive industry. And if you were able to ask what impact it has made so far, you can look at the 6 gray boxes. So if it talks about the influence this revolution has caused, first block on the left states that due to evolution of connectivity, the information which was available in silos are enabling the vehicle to become an intelligent terminal. Then in the past and current, we have humans driving the vehicle. In the future, you will see fully autonomous vehicle. Then in the future, we will also see car as a source of energy or mobile energy, which was and is being seen as the energy dissipation machines. Similarly, if you look at the right side, we are talking about sharing a car instead of the notion to own a car, which would essentially enable you to have a vehicle access on a need basis. Next is manufacturing, which has evolved significantly. So we talked about additive manufacturing, Industry 4.0, digital manufacturing, and so on, which is becoming connected and intelligent today. And lastly, vehicle, which was looked at, tool for movement, only is being used as a transportation service. If you look at the bottom blocks, we are going to witness new development methods, new manufacturing method, new core technology, new maintenance method, and even new architecture. So essentially, we are talking about transformation from new automotive products to new mobility ecosystem in future, which would largely be impacted by the major disruptions in the automotive industry, such as electric traction, automated driving, connected car, and mobility on demand. So this also necessitates the need to reshape engineering education, and academia definitely has a key role to play here. So I'm going to cover this again from automotive perspective. Now, feedback from FICITA corporate members also shows that the traditional mix of science, technology, engineering, and mathematics, which we call STEM skills, will remain an important part of the skill mix. So the classical automotive engineer with profound knowledge in mechanical engineering, mechatronics, and material will still be a necessary skills. However, in the context of, say, electrified, connected, autonomous, and shared mobility, the qualification profile of a universal engineer with a deeper understanding of other engineering discipline will gain increasing importance. And in general terms, companies anticipate a shift in the requirement from, say, a pure mechanical engineer profile towards a mixture of mechanical and electronics or mechanical and software engineer profile. Probably one of the responses was given on the same line. And how do you acquire these skills? So the one circled in the purple color are the skills you pick up when you're in the college, and the one in the gold color are the skills you acquire when you join industry. And of course, there is an overlap where you pick up skills both in industry and college. This is how we need to reshape the educational concept, and make student workplace ready. So how do we do it? You can get internship, you can work with industry mentors, you can participate in advanced student competitions. And this also holds true when you join industry, because you need to continuously upskill yourself even when you join industry. So from the ANSYS perspective, now there are various areas we talked about earlier and various technology trends. So if you look at ANSYS technology strategy, so this is 12 areas of our investment where we are investing in future, and all these technologies are, if you look at this, is relevant from the current market as well as how we are reshaping the way we are looking at engineering our product. So we are looking at new technologies around advanced numerical methods, meshing algorithms, visualization and AR, VR, platform for multi-physics simulation, and AI and machine learning to train AI method to improve simulation. Then we are talking about HPC, high performance computing, or quantum computing, and all kind of parallelism, cloud computing, reduced order modeling and digital twin based on hybrid and data analytics. Then computational method in the new areas such as ICME and additive, which is also gaining a lot of traction because you want to design with, till now you have been designing a component knowing that what materials you have, but tomorrow you will be designing the component with the new materials. So that is the kind of promises which simulation brings on the table. And also healthcare as the one of the new vertical where we are putting a lot of focus and energy. So here I'm going to cover one of the areas from long-term technology strategy and AI/ML applied to the simulation. So we have identified 4 types of value proposition using AI and ML and simulation: customer productivity, where linear solvers, parameters tuning, say Bayesian learning. So example on the right shows reduction of time. For one of the cases, you have for flow over cylinder, where you're talking about plotting the velocity contour. So improvement the quality of the auto-generated contacts, and also the reduction of time by 20% for AMG solvers. Then we are talking about augmented simulation. So physics informed neural network, PINN, what you call it, for heat transfer. So example on the right shows that pin simulation running 100x faster with the same accuracy. Then revolutionizing the engineering design. So fast topology optimization and generative design. So this shows that some of the example on the topology optimization. Then we are talking about business intelligence, where resources predictions. So before you actually fire a simulation, you should be able to predict what is the kind of memory it would require, what would be the runtime, so that you can do resource allocations and predictions. And we are also partnering with various partner ecosystems such as to make progress, NVIDIA, Google, Geminis, Minds.ai, and with university as well. So we have been working closely with Stanford, CMU, Michigan, Brown, and ISU to lead such engagements. Now switching gears to ANSYS in academia. So ANSYS is also investing in the talent development for the future. On the field, we are engaged at 3,300 universities across 91 countries, and who are you leveraging ANSYS for teaching and research. Now, Granta, which is a tool for material education, alone is being used at 1,500 plus universities. Now, around July 2020, we launched ANSYS Innovation Courses, which is based on MOOC anatomy, and we realized that we need to contribute to digital education. A lot of demand and ask was coming on providing quality education materials, so that we can this would be our endeavor to bridge that gap between what industry asks and what we are teaching currently. So it has seen more than 319K plus unique users, with India comprising of majority of the traffic. So I would say India is in the top 2 next to US, or in some cases even more traffic is coming from the India side itself. And this has also established our belief in the need of reshaping engineering education in India. We have seen more than 2.14 million plus free student product downloads spanning 148 countries, and also 1.12 million plus unique user visiting our platform, ANSYS Learning Forum, which is basically a collaborative platform, learning platform for working together with your peers across the globe, and also to seek technical support. So this helped us understand, there is a definitely an appetite of learning in the market, and this is our endeavor to contribute to the academic ecosystem. And we are also partnering with several key anchor universities to develop this coursework, which can be made available to all. So what are the benefits of ANSYS academic program, if I put it in a nutshell? So we have an academic program with a clear vision and goal of helping students succeed. So leveraging ANSYS academic program, there are some of the ways by which we interact with academia. So namely curriculum enhancements, support to student competition, capstone project, research grant, and also to boost research. Our broader goals are to inspire, so every student must know that simulation is key for their careers, to train students in simulation, and also boost student career by creating an ecosystem where we can connect students to companies looking for simulation trained engineers. So this is a very exciting time, and you should stay tuned for more news where we are trying to develop a learning community where we will be bringing industry partner, academic users on the same platform to help them interact. Now, ANSYS has a strong route to academia, and we feel privileged to have partnered with key research institutes. And I'm proud to state that ANSYS today is used in almost every engineering college in India in at least one of their departments. And we also believe in supporting the academic customers by being a key enabler in industry academia ecosystem. and IIEST Shibpur is one of the torchbearer in such initiatives. So here are some of the programs that we have, like fellowship programs, Center of Excellence programs we have established with various IITs, ARAI, Cummins College, Trust Park, and so on. Now, this is very close to me because I was personally leading various such engagements. So ANSYS also believes in giving back to the society, and we have always looked forward to working on projects of larger societal importance. So when pandemic struck, and till today, I would say that world is still adjusting to the new normal, we proactively reached out to leading research institute on COVID-19 projects. Few of the important collaborations are shown here. So during first wave, if you should see the first two, so during first wave, we worked with a group of volunteers at IIT Ropar in the design and simulation of negative pressure room for isolation ward, and with IIT Kanpur and Noka Robotics team on low-cost ventilator project. Then also we worked with IIT Bombay on mobile booth and cloth mask simulation. And the story of this low-cost ventilator project is also captured in the book, The Ventilator Project by Professor Amitava Badnepadhyay and Professor Shrikant Sastry. During second wave, when oxygen became an essential commodity, and we interacted with multiple institutes working in the oxygen conserving and oxygen delivery projects. Two of them are mentioned here. So we could design and develop indigenous oxygen plant, which you see on the bottom right, in a record 90 days. And as of today, 10 oxygen plants are commissioned across India with a target of 50 plus across the country. So similarly, we helped ramp up the development of oxygen concentrator as well. Now I'll cover some of the important building blocks for continuous learning process. But before that, it is important to understand where ANSYS is being used. Now, I know the audience is majorly from mechanical department, but if you look at how ANSYS was used conventionally, then ANSYS, the mechanical, aerospace, civil, electrical, and automotive are definitely one of the oldest user of simulation and ANSYS. But today, if you look at the new departments such as biomedical, physics, there you can see the need of getting the understanding of computational engineering. They realize the need of computational engineering, and we see a lot of traction and requirement and people working in that particular area. So today you can say that ANSYS is pervasively being used across the engineering discipline. So the various building blocks to help students, the first one is on the ANSYS student product. So in order to equip students with necessary tools to learn new technologies, we have various student products. Students can download this on their personal laptop and start learning. We have ANSYS Discovery, which is based on instantaneous simulation technology. We have ANSYS Student, which comprises of mechanical and CFD, which remains most popular. Recently, we have added ANSYS LS Dyna and ANSYS CADE for explicit dynamics and model-based design. Latest one, which was also a long pending ask from the academic customer, is on the low frequency and high frequency tool. So we have added ANSYS Electronic Desktop, which has bundled ANSYS Maxwell for low frequency, ANSYS HFSS for antenna design, ANSYS Q3D, and ANSYS iSpec for electronic thermal management. Second one is ANSYS Innovation Courses. They are online, self-paced, and physics and engineering courses designed for engineers, students, and educators to deepen their understanding of selected subject and also to reinforce relevant concepts using ANSYS simulation environment. So this is how we are trying to make it different. We are not trying to replace the curriculum. We are basically complementing what you learn in curriculum by providing you more contextual examples, because we have various industry experts with years of experience working across various industry segments. So we are using more contextual example from real life problem and helping it reinforce what you learn, what various concepts. So say for example, if you look at fluid dynamics or heat transfer, so we'll introduce you with the concept of heat transfer, and next step would be you'll be subjected to one of the workshop where you'll be reinforcing that concept by using simulation based examples. So it helps us understand that it also leads to retention of what larger retention of what you learn and what you study compared to the conventional process. So some of the statistics, we have 200 plus free IIC courses hosted on our website. So they cover various disciplines where we have fluids, structures, electronics, STEM. Then we also added on materials, then also on the photonic side. So I'd encourage you to visit this website, courses.ansys.com, if you haven't already, and start learning. These are all free courses for you to learn and come to speed. And another important aspect is the technical support to student and faculty members working on simulation projects. So ANSYS Learning Forum is a go-to place for students, educators, researchers, and industry engineers to engage with peers and ANSYS experts. You can discuss installation and licensing, simulation topic, physics topics, or even ANSYS innovation courses if you are taking. So on the forum, you can engage peer-to-peer and also with ANSYS expert. You can browse through the answers to your query. So if you're working on any simulation projects and if you post your query, your peers across the globe as well as ANSYS expert would be moderating an answer to your queries. And if you just simply browse through the available questions, you might find your answers already available there. And then you can also check various tutorials. Last piece is on the ANSYS Learning Hub. So if you're looking to upskill or improve your skills or maximize your productivity or need the right solution, ANSYS Learning Hub is the answer, or ALH as we call it. So this is a learning management system and centralized knowledge portal. It offers you various modes of learning. So we have self-paced learning where you have 900 plus recorded video modules. You have a collaborative learning room. So if you're picking a particular role, so one of the key highlight is the role-based learning approach here. So if you aspire to be, say, thermal engineer, then we provide you the curated path to learn those. Say it is divided into core module, fundamental, and as well as elective modules to build expertise on that and become proficient in those subjects. So we have 45 plus topic specific learning room. Then we do live classroom classes we used to do earlier before pandemic, and we are trying to come back to that through hybrid model. But I have hopes that we'll come back to the time when we'll start conducting this live classroom sessions as well. But you have unlimited access to live virtual classes where you have 300 plus virtual classes conducted throughout the year in various time zones. And on top of that, you have various course materials spanning various physics I talked about earlier. So you have 240 plus courses and 1000 plus workshops. So I think we have already overshot the time. So in the interest of time, I'll not play this video. This is more of a overview video of ANSYS academic program. And with this, I wrap up my talk. Thank you. And thank you for your time and patient listening. Let me stop sharing so that I can switch on the cam.
Thank you, Mr. Abhimanyu, for your session on ANSYS and its role in future industries and opportunities for students. Mr. Abhimanyu, I just have a common question on behalf of all the students. What would be your personal advice to students on looking to become industry ready, and how do you think can they leverage ANSYS suite of products?
Okay. So Mr. Ghosal and Professor Sarkar spoke about various such aspects. You know, there is no shortcut. So when you talk about simulations, ANSYS or any tool is just a tool. You need to develop a very profound understanding from what you learn from the curriculum. You know, what you learn, those hard work is required because you need to understand what is happening behind the hood of such tools. Only then you will be able to appreciate what you're solving, and you will be able to make meaningful or generate meaningful insights. So, and if I talk about my personal journey, so when I was doing masters from IIT Bombay and earlier my bachelor's from RVC Bangalore, so the concept that I did during my IIT days, because we are subjected to various practical knowledge. So I started appreciating simulation more after I gained theoretical understanding of what various schemes are. If I talk from CFD perspective, because many of the audience are from mechanical department. So if you're learning, say, CFD, generating colorful fluid dynamics is very easy because you can click few buttons and it will give you the velocity contour and pressure contour. But what is more important is the kind of schemes that you select, the discretization scheme, understanding their limitations, and if you're running into, say, challenges, how do you troubleshoot them? And that will come only when you go through the mathematical understanding of those topics. And once you go through that, you'll start falling in love with this subject, because engineering simulation today holds a lot of promises. And during COVID, you would have seen that we could ramp up the vaccine production only because we are able to do a lot of things virtually. You know, before even the vaccine formula came out, the industries were ready with their production cycle. Like, what would be my mixing efficiency? What should be the impeller design? What would be the RPM through which there should be a maximum efficiency of the vaccine which would come out. So this is something which is very promising, and I'm personally very excited when you talk about the current trend where engineering simulation is heading. And during pandemic, when a lot of labs, because when I was interacting with various IITs and IIC Bangalore, a lot of labs were closed. So the access to the physical infrastructure were limited, and same was happening with the industry as well. So they invested heavily on this digital technology. So many industry are torchbearer, you can say they were already adopting, but in academia, where many professors I know were pure experimentalists, they also switched to simulation, because before this pandemic could come down and they were given access to labs, they were able to develop a lot of you can say what if scenarios of their own experiments that they were supposed to do later. So they understood the power, and to student I would say that you need to invest a lot of time on building the fundamentals, gain additional skill sets, because that is more challenging. I mean, when I compare it with my time, just a primary skill set of mechanical engineer was sufficient. But today in this world, when technology, a lot of technology has come, you need to develop this skill set, additional skill set, as Mr. Gosal also earlier spoke about, to become more employable, as you termed it, that some of the questions came, because industry is looking at you in that way, that you joining industry, you should be able to contribute to the new innovations that they aspire to have. Probably sorry for that long answer, but probably I wanted to connect it with my personal journey.
Thank you so much.